Hi everyone, it's Ms. Atkinson. I am really excited to hear from the few of you who have come in for tutorials. I'm going to start out all of these videos with some announcements and then what I'm expecting of you this week. So, assignments are going to be posted on Monday and due Friday from here on out. Presentation points are going to be videos that you submit through a comment in the assignment on Echo. Tutorials are going to be hosted Monday through Friday, 10 to 11 a.m. through Zoom. The link is in the announcements on Echo, and I really need you guys to pay attention to those just in case there's any changes that come up. This week, you guys are responsible for watching this video on Slant Asymptotes. I want you to turn in the limit homework, and there is an online classroom assignment which is just going to tell me what access you have to technology and give me an update on your life. Okay, let's get started. Hey everyone, so we have talked about rational functions for the past couple of weeks, and we are going to do one more thing with them. So, if you notice, I have a rational function right here, and I have taken it and used the properties we know about vertical asymptotes, x-intercepts, and horizontal asymptotes to plot my graph. So I know that when I set the denominator equal to 0, I get an undefined function, which would give us a vertical asymptote. So that means I have a vertical asymptote at x equals -5, which is this line right here. And then I use the quadratic formula to factor the numerator, which is the -b plus or minus the square root of b squared minus 4ac all over 2a, which is a formula that you found way back in the semester in the fall. So that part isn't necessarily crucial, so we're going to go ahead and move past it. You can always come to tutorials and we can talk about it, but we notice that the degree of the numerator is greater than the degree of the denominator. This 2, or the highest exponent, is the degree, and this 1, which we don't write because mathematicians are lazy people, and so we know that 2 is greater than 1, so there's no horizontal asymptotes. And then what you can do is you can plot points by choosing an x, substituting it into your function, and then getting an output or a y value. But I just used a graphing calculator because that's not necessarily what we're focusing on at the moment, but you are always welcome to. So, what we're going to do now is we are going to try and find the formula for a slant asymptote. It's also called an oblique asymptote. So, essentially, a slant or oblique asymptote on a graph is any asymptote that isn't exactly horizontal or exactly vertical. So here, you can see that there's a line right here in my horribly drawn graph that these functions are getting arbitrarily close to. And remember, we discussed that arbitrary means that it doesn't necessarily matter. It could be so freaking close, and then it could also get half that closeness, and even closer and closer and closer. So that is what arbitrary means. So I'm going to go ahead and draw a line to represent my oblique asymptote. And we know that a line has the form of y equals mx plus b, where b is your y-intercept and m is your slope. So I'm going to do this example right here to show you how you find that equation in the form of y equals mx plus b. So notice that this is not factored, so we're going to leave it in the unfactored form, even though factoring did tell us what our x-intercepts would be, which were 1.59 and 4.41. Okay, so here we go. We have, sorry, it's kind of difficult to do things from home. We have the numerator and the denominator. So what we're going to do is we are going to do long division. So we set the numerator inside of this, I'm unsure of the name, and we should set the denominator on the outside. I know this is weird, but it's how I remember it, and we live in Texas. So if this is a cowboy and this is its horse, the horse stays outside of the house and the cowboy goes in the house. So if this is the cowboy and this is the horse goes outside and the cowboy goes in the steeple. Whew, I don't know why. I can do it, but whenever I explain it, it's really hard to communicate math. So we're gonna go ahead and scooch this down here so we have more room to work. So now we notice that whenever you're doing long division with, let's say, 24 and 3, the first thing we do is we see how much this can go into this number right here. So we're gonna do a similar approach, but now we're gonna be using x's and not just numbers. So how many times can x plus 5 go into x squared minus 6x plus 7? So you'll notice that x squared is equal to x times x. So what you can do is you can say x right here. So just like in this case, we notice that 3 can go into 24 8 times, and then we multiply 3 times 8 to get 24, and we subtract that number. What we're going to do here is we're going to multiply x plus 5 times x, which has to do with distribution. So over here we have x times x plus 5, and we're going to distribute to get x squared plus 5x. So now we are going to write that right here, but we also have to subtract it. And that means we have to distribute this negative. So this stays negative, and this actually becomes a negative. And then we can subtract. X squared minus x squared is 0, which is what we are trying to get, just like in this case. And minus 6x minus 5x is minus 11x plus 7. So now we can keep going. And we know that x goes into x how many times? Or x goes into 11x how many times? Minus 11 times. And I know you're supposed to put that over there. That is my mistake. Pretend it's above this 7. So now, if I multiply this by this minus 11, you get minus 11x minus 55. And I'll show you that distribution over here. So we have minus 11 times x plus 5. And then when we distribute, we have minus 11x minus 55, because we're going like this and distributing it in. And then, once again, we have to subtract the whole thing. So then we distribute that negative across both of them. So 2 negatives becomes a positive, and 2 negative becomes a positive. We can get rid of that. So minus 11x plus 11x is 0. 55 plus 7 is 62. Mental math. And then we get 62 as our remainder. So if you look back at our function, I'm going to write it down here. We have f of x is equal to x squared minus 6x plus 7 over x plus 5, which we now know can also be rewritten as x minus 11 plus our 62 remainder over our divisor, which is x plus 5. And now, if we look at this formula, we can see a y equals mx plus b right here, where our m is 1 and our b is minus 11. So that means that this point right here is minus 11, and this line is y equals x minus 11. And that is how you can find your slant or oblique. Okay, one more thing I wanted to point out that I thought was really interesting is that rewriting the function in this form is actually really helpful when it comes to picturing the graph. So this can be thought of, I guess, not rewritten, as the distance from this line, x minus 11, to our function right here. So if you substitute in points, so let's say we start at -4 because -5 is going to give us an undefined point. If you start at -4, then this term becomes 62 over 1, or 62. And then if you go to -1, this term becomes 62 over 4, which is less than 62. And so the distance from this to this is getting smaller and smaller because this formula has x minus 11, and as x increases, this goes to 0, or it becomes 0. So 62 over infinity plus 5 is going to be super, super, super small. And it's just going to keep getting smaller and smaller. So it's going to be x minus 11 plus a little bit. And then that little bit is going to get smaller as we keep going and increasing and smaller until it becomes so arbitrarily close to this line that it's basically just x minus 11 plus a really small fraction. And the same thing goes when you start at -6, and then you get increasingly negative. So as this approaches negative infinity, this term is also going to get really close to 0. So it's going to be almost equivalent to x minus 11 plus a little bit more, which I thought was super interesting. So I hope you guys have a great day and you are enjoying yourselves learning from home. I wish I could ask you all how you were doing 1 to 5, and I hope this video helped you with the assignments.